Bismillahirrahmanirrahim. Today we are going to start the topic simple harmonic motion, which is somehow also known as SHM. Basically, it is an oscillatory motion. Oscillatory motion. By saying oscillation, we mean that the object is moving to and fro. Simple harmonic motion can be in one dimension, can be in two dimension. Today we are going to discuss only one dimensional case, and which includes mass attached to spring. The other one is pendulum case, which we would discuss later, inshallah. Okay, let's begin with the diagram. Okay, this is the spring, mass attached to a spring, and I'm going to discuss these cases with you here. While drawing the figure, you need to keep your focus on the number of strings, and in the cases which I'm going to discuss, 1 2 3 4 5, they should be 7 6 or 7. Okay, I would say that it is compressed case. Okay, let's name it as plus x, 0 and minus x along x-axis. According to Hooke's law, we can say that F is directly proportional to the negative of displacement. Here F is the force, x is displacement. When we change the proportionality into equality, we all know that a constant comes. Here this constant is spring constant. And when we talk about this spring constant, then we say that if the value of k is larger, then the spring is stiff, and if the value of k is small, then the spring is soft. It tells about the stiffness of the spring. Okay, stiffness of spring. To calculate the value of k, we would do this following mathematics, starting from second law of motion, F equal to ma. We all know about it. Okay, I'm putting these signs to indicate that these are vector quantities. When we compare this equation with this equation, we get the result ma is equal to minus kx, a is equal to minus k upon m x. K and m are constants, and they would remain constant throughout our experiment. So we can replace them from proportionality. I have forgot about it. Negative sign indicates that force and displacement are always opposite in direction. I think so now is the perfect time to discuss these cases. Let me name these cases A, B and C. Okay, A, B, C. Okay, and when we see here, it is at mean position. So we can say that it is for mean position. Okay, and here we should know that x equal to 0 on x-axis, and potential energy is minimum, kinetic energy is maximum. It is B is one negative extreme and C is positive extreme. Negative extreme and positive extreme. When we talk about negative extreme, then we say that at x is equal to minus x, potential energy maximum in this case, and kinetic energy is minimum. Here same is the case over here, potential energy maximum and kinetic energy minimum. Here we need to understand about potential energy and kinetic energy. By definition, we all know that potential energy is equal to mgh norm in normal cases, but in our case it would be x. X can be positive or negative accordingly. And when we talk about kinetic energy, then it is half mv square. And as we can see that kinetic energy is minimum at extremes, so we can say that V is minimum at extremes and maximum at mean. Okay, now moving further, we have deduced this result: acceleration is directly proportional to negative of x. And okay, here it is in at mean position. When we stretch a spring in outward direction, then it would try to restore itself towards mean, it would try to restore itself to its mean position, and similar is the case here. Here restoring force is towards mean position, and here it is. So that is why we can say that acceleration is always directed towards negative x. Restoring force is responsible for the oscillation. It would start oscillating whether I stretch the string from this position to over here. If I pull this string, then then it would try to restore itself towards mean position, and it would not यहाँ पे ये आके रेस्ट पे नहीं आ जाएगा, यहाँ से ये आगे मूव करेगा and it would start oscillating to and fro. That's why it is called an oscillatory motion, simple harmonic motion. And time period, in this case time period t is equal to 2 pi square root of m upon k. So it is a simple harmonic motion. I would be very obliged if you ask questions in comment, and I would be answering your questions. Thank you.